Let's summarize what we learned so far. In fact, in the past couple of weeks, we basically focused on one topic, which is generating function. So what is generating function? Laplace used 3 sentences to explain what is generating function. Well, nothing more than a polynomial. And what we are concerned about is a sequence inside a polynomial. This is when we call it the generating function, because the generating function contains a sequence of coefficients. Although the concept is very simple, its usage is often compared with a Hahn with a sequence of numbers. But it brought us many different applications. The most important of them is solving linear constant coefficient homogeneous recurrence relation. If we already have linear homogeneous recurrence relation with constant coefficient, we can directly write its characteristic polynomial. According to different roots of the characteristic polynomial, for example, there are multiple roots. They could have distinct real roots and conjugate complex roots. According to these different situations, we vary the coefficients and establish its general term expression. According to this initial value, we can easily construct a system of equations and compute all the general term expression. So if we know how to use generating function, although it seems like just a simple function, however, after a certain abstraction, it helps us to solve almost all linear homogeneous recurrence relation with constant coefficients. Apart from this, we can also transform the generating function of these 3 lines and not just use x raised to the k as a general term. In order to solve permutations, we also introduced that x raised to k divided by k factorial as a general term of a generating function. One is called the ordinary generating function, and the other one is called the exponential generating function. The difference between the 2 generating functions is in its uses. As for ordinary generating function, it's mainly aimed to solve problems related to combinations. And if you see permutations, you should first use the exponential generating function. In the traditional ordinary generating function, we often use 1 over 1 minus ax because its coefficient is a raised to k. Well, for exponential generating function, we often use the exponential expansion of e to the x. Finally, we not only introduced the linear recurrence relation with constant coefficients, we also told you about some magical sequences. These sequences have special recurrence relations. Some of them are not even linear, but it can help you to solve a lot of problems. There is also a very interesting question. In fact, a question that sticks to combinatorics throughout. In the very beginning, starting from the first chapter, I explained permutations and combinations using ping pong balls that would be to put the balls into boxes. Until now, we still have the same problem. With n balls to be put into n boxes, there are different methods, different problems. Where is the difference between the questions? Are the balls identical? Are the boxes identical? Is the box allowed to be empty? So, according to these constraints, naturally we can have 8 different questions. I hope the students will look at this as a homework and think carefully about the different solutions to these 8 different ways of placing balls in boxes.